Next talk is from Manuel Núñez. Manu. He works in BBVA, which is a major bank in Spain, and he has an interesting talk about protocol buffers and how they are using protocol buffers. So,
thank you. Good afternoon. My name is Manuel, as Xavier said. In my department, what we mainly do is we design and code algorithms for calculating the price of financial products. This is something that we do completely from backend to frontend in C++. We stay true to our language. And we design our solution as a whole. We really don't have much that much interaction with other languages. However, inside our company, times are changing, and there is all those new teams that are programming in lesser languages. They want to use our libraries because at the end of the day, the main code, the code that calculates the price of those financial products, is writing in C++. And this is a problem because we never gave much thought about how other people from other languages are going to call our functions. What I want to address during this presentation is these three main questions. How to expose our interfaces to make easier for other people to call C++ libraries. This drives us to the second question, how to serialize the data that we are going to share between those people. How is going to be the language support? Do we need to create different solutions for different languages, or can we gather all together on the same solution? But, spoiler alert, protocol buffer is going to solve all these questions. Let's start from the beginning. This is an example of any of our interfaces. We have many functions that receive input and return output, and they do very complex stuff. They do a large amount of time doing calculations, so they are not easily replicable in other languages. And input and output are C++ classes. So how can people who code in C#, Java, JavaScript, even this crazy guy in JavaScript trying to call directly C++ libraries. And they try to rely on Swig, on solutions like SpyBind, or even JNI, all of them with different degree of success. And all of them makes them and us to code different tailor-made solutions for every problem. We tried in the past some other approaches. We tried to expose XML interfaces, CSV interfaces, because in banks, everybody loves CSV. Even Corba, we tried to use Corba defining as an ADL. But all of these solutions brought their own problems. With plain file interfaces, we have problem of encoding. We need to inform all our clients that which encoding are we using. We need to maintain parsing code to translate all those files into the actual classes, and the same goes for the clients. And Corba. Corba brings its own problems to the table. So in the end, starting from the main interface, we decided to create two wrappers over the main interface. The one we call the service interface, who is going to provide an access point to our library from every language as a service, and a C-native interface, who is going to provide the same entry point, but from an inter-process perspective. The main point here is that the input classes in the C++ interface and the service interface are the same classes, and the native byte array in the C interface is the serialization of those classes. How can we keep in sync all these classes and the serialization algorithm between languages? Well, protocol buffer It's going to give us the tools to define those data for the interfaces in a quite easy understandable language, and it's going to take care of the code generation for every language. It's going to keep track of the serialization algorithm between all those languages, and it comes with multi-platform support. Here we can see an example of how can you define data using protocol buffer. They are quite straightforward for C++ developer because it's like defining an struct, which they call message, but only using simple types and without member functions. Here we can see integer, string, and the simplest collection type, which is called repeated. And protocol buffer is going to serialize those data in binary format, which you don't really care, don't have to care about how they are going to serialize, and also in JSON format. And this is quite useful for us too, because you can go back and forth from binary to JSON, JSON to binary, and binary to the actual struct, JSON to the actual objects. The JSON serialization allows us to replicate production cases, because in production code we of course only use binary serialization. You can also design and build a regression test framework based on those JSON, because if your inputs are protocol buffer defined data and your output is protocol buffer defined data, you can always dump to JSON and read from JSON those data. So, okay. So far, we can use protocol buffer to define the input and output data, but how can we define the actual service? Protocol buffer comes with a plugin extension capability that allows us to extend the language through plugins. There are many plugins out there, but I want to talk about two of them. The gRPC service plugin, which is going to solve the service creation, and the data validation plugin, who is going to help us to make a robust interface. Using the gRPC service plugin, we can now write, using this new syntax service and RPC, they are like classes, but no, because they cannot have data members. You are only define the functions you want. You are only define your services. And you can use, and you must use as input and output messages defined using protocol buffer definition. This is going to translate into an abstract class with a virtual method that you have to implement. So in this case, we just, as I said before, we just wrap our actual class, our actual interface, or original interface, do complex stuff, into the new wrapper generated by gRPC. I want to point out that here, what gRPC is giving you is the actual input pointer and output pointer. They are the actual classes. It's not serial. There are no byte arrays that you have to deserialize. gRPC is taking care of the serialization for you. Writing some boilerplate code is quite simple, actually. You just set an address on a port, create a server builder, register your new gRPC service, and you have a service up and running based on your implementation. I want to mention also that gRPC supports reflection. So for any client to connect to your gRPC server, they don't really need to know how did you define your data. They can interrogate your server, request how many service you provide, what are the data, what are the struct of those data. He can build on the fly things like this. gRPC is the software that the crazy JavaScript guy from the beginning uses to interface directly with C++. This interrogates our service, and as you can see, it builds a complete web interface that lists the actual service, the actual data, and so far. So we have defined the service interface But what about the C interface? What about those people who want to call embedded in their code? Well, this is actually almost the same as the service interface. You just need to call the deserialize and serialize method on your own because nobody's taking care of you. I'm aware of the leak of memory here. I'm returning the byte array and I'm forgetting about it, but for the sake of clarity, I want to keep this example simple. We have defined the two wrappers around our main interface, and now everybody can, from any language, can use our libraries. We have defined the data that those languages need to use to call our services, but can we enforce some kind of data validation in the code? Well, yes, we can, because as I said before, using this language extension feature through plugins, we can add rules that validate the data on the messages interchanged by the service with protocol buffer. In this case, I'm stating that I require this field from the message input. I don't require the second field. And I'm stating that the result is going to be greater than 0. So with these three tools, in the end, I'm establish a contract between our client and our services. These new extensions are going to translate in validate functions that you can call on any protocol buffer defined message. If you have defined rules for validation is going to exercise those rules. If you didn't define a rule, the validation is going to pass without any more problem. I forgot to call validate on the output, but that is something that the client can also do. That is not something that you call only the server side. What about interface evolution? Because I would like to think that interfaces are going to be stable, are going to be compatible always, but they are not, they change. And protocol buffers provide some kind of backward compatibility in front of those changes. Protocol buffer is going to be compatible, renaming parameters and adding parameters. You can, and previous serialize, previous JSON you keep for your test are going to give you no problem deserializing them. But it's not compatible removing parameters, reassigning ID, or modifying parameter types. In essence, it's not compatible with anything that's going to mess with the serialization algorithm. So summarizing, we started from a C++ interface that do very complex stuff, and we created two wrappers around it, a service interface that anybody can call, interrogating using reflection to our service, and a C-native interface that people can use to call us from the same process, but they need those data definitions to know how to call us. So what did we solve? How do we now expose our interfaces? We use mainly gRPC to expose our interfaces, aside from C++. People who call us from C++ still use our main interface. How do we serialize those data? Well, we rely on protocol buffer data serialization and definition. And how to support different languages? Well, protocol buffer is going to take care of it for us. It's going to generate code for all main languages, you can imagine. And this is why we like protocol buffer mainly, because the serialization algorithm is the same for everybody, and you don't have to care about it. Because the JSON parsing is free, so you can serialize and deserialize from binary to JSON. Because it's a type language definition, and this, I think this is quite important because from a JSON file, sorry, what you get by parsing is the actual classes with the actual type. That's something we didn't have when we had to keep the maintaining of the XML parsing code. We really didn't have information of the underlying types. We like that it's extensible through plugins, and we have a very huge language support. And that's it. Thank you very much.
Questions?
I just want to know if there are, from what you've shown, the services are exposed in a kind of request response. Is there server-side events?
Yes, sorry?
Are there server-side events supported, like unsolicited?
It supports stream events, if what you are asking for, and mainly as request response events.
Does it work like in a subscription kind of model? Like I want to subscribe to these events?
I think you should handle that part if you need to keep track of a subscription, yes.
Okay, thank you.
Thank you. More questions?
I mean, they're mostly behaving like the actual interface that you call for Server Plus, so you expect like a request response.
Hello, thanks for the talk. I don't know in the current version of protobuf, but before at least it was existing the option to define fields of a message as optional. So that's what we was using for basically removing this. Did they remove it? You are not using it for another reason, or how that works?
Yes, optionals, I think it got dropped in one version, it got rescued again in the next version. So we just didn't want to rely on that, and we moved to that plugin who has a more extensive capability, because it's not just optional. You can define rules like greater, less, that maybe fill in a collection, so it's more rich.
Definitely, yes. Okay, thank you.
More questions?
Thank you. My question is, does a protocol buffers interface allow for easy testability of the services? I mean, can you treat your services to be used in an integration test and inject some input and expect some output to another different service?
Yes, we actually do we integrate, as I said before, we use the JSON serialization to integrate in those parts. We mostly use the gRPC interface to be able to reproduce those tests, to debug those tests, because here if you realize there is a raw request JSON tab in the second one, so you can put there your request and just debug your code in C++.
Another curiosity question. Does each function or the interface have to be unique, or does it support any type of overloading?
They have to be unique.
I mean, same name of the interface, but different types?
No, they have to be unique. Yeah. You can gather all together inside the definition. Here, I mean, inside the service definition, I'm only defining one function. You could define many, but you have to keep unique the names.
That's all. Thank you.
Thank you. Any other question?
So how do you keep version controlling in proto buffers?
Good point. What we ended doing was I didn't use in those examples, but you can add an namespace. What protocol buffer tells you is that you should use your namespace versioning. I don't really like it, but that joined with the retrocompatibility capabilities, I think we don't really change the namespace ID that much. But apart from that, there is no other.
It is not clear to me how do you manage to actually communicate with other languages. So you are using gRPC in order to communicate, I don't know, Java or JavaScript.
Yes, for example.
That's the only way. You can't do it directly like protobuf thing or.
You have two ways of doing that. If you started a running service, any language can interrogate your service and request for how many methods you have, how is the form data.
But that's using TCP IP sockets and things.
More or less.
Okay.
Yeah, exactly.
Okay.
But if you want to use intra-process, In our case, using the message definition, we provide generated code for Java, JavaScript, and other languages to be able to call us. So they only need to use those classes, serialize, convert to a byte array, and use something like, for example, J9 to call the actual interface.
Okay, understood.
But maybe the big difference here is that you don't have to care about the serialization because...
Yeah, you got it for free.
Yes.
Yeah, okay, thank you.
Hi. We were discussing before with some colleagues here about relying on tools to generate code.
Yeah.
I guess that this is quite performance critical. So I want to ask about the performance of the code being generated by the tool, whether you measure it, whether you looked into the code. What is your experience with that?
When you look into the code, it's quite ugly, actually. There's a lot of boilerplate in there, mostly in the validation code. We really didn't enter into measuring the performance because the nature of our developments make for them to take like minutes, maybe 15, 10, 20 minutes into calculation. So the actual time during serialization for us is not relevant. I look for other alternatives different from protocol buffer, like Apache Thread, for example. Everybody points out that protocol buffer is better because their serialization is faster because they use their own memory allocation. They use this kind of trick of not serializing fields you didn't fill. So, but I don't have the numbers. Thank you.
What can you tell about the threading model of the gRPC? How many threads? How many threads does it use? Can you interfere with it? Can you manage it?
I think you have to manage that yourself. You don't really when we use gRPC, we really didn't use it as a service managing the threads here. Let me go to the implementation interface. We just using it monothread. I mean, what we try to address in our actual problem is to mimic the actual C++ interface, not providing a service of functionality.
Okay, thank you.
Thank you.
Thank you. So, last one. This is the last question.
Hi, it's more of a remark about the threading model. Actually, if you use the Google gRPC provided library, you have by default like 7 threads started in your...
Sorry, I didn't get you.
When you use the gRPC library provided by Google,
yes,
you have like 7 threads started by default, and it's impossible. I did it like maybe 2 years ago. At that time, it was impossible to limit those threads.
I don't know. I really didn't look into that. I mean,
yeah, I'm just saying that this code example that you posted, it actually uses 7 threads in background.
It's using the same address?
7 threads.
In background, okay.
Yeah. You can write your own server loop, and it can use the amount of threads you want. But this example uses 7 threads.
Okay, thank you.
Okay, thank you very much. Thank you, Manuel.
Thank you.